we are picking back up in 2.8 where we left off, which is example 2. I think it's still on here. If you recall in example 1 yesterday, we just looked at a factored polynomial. That was the nice part, it was factored. And we found where our equation equaled 0. And then we looked at the positive and the negative intervals. And I don't think it was in your class, I think it was in the other class, but I kind of sketched on here, okay, if it's negative here, it'd be below, it'd have to cross here, it'd be positive, it'd have to touch, and it'd be positive. So that was just kind of a sketch of what the shape of the graph would look like. And as I said, I think I put that on in 5th hour, but not in your class. Okay. Example 2 has us solving algebraically. When we get to example 3, we'll specifically start talking graphically. Now, with the algebraic, and you have, so what I say, the first 3 problems are like the first example. The next handful of problems are like this, and then the end of the homework is all graphing, I know. Okay, but they ask us to solve 2x cubed minus 7x squared minus 10x plus 24, and then greater than 0. Now, as I said, directions, we have specific directions here. We're asked to use algebra and a sign chart. So kind of similar to what we did last problem, where we looked at a sign chart and what's the graph doing in each of those sections. What's different about this one to the previous problem? The previous problem, we could nicely find all of our zeros right off the bat because it was already factored, yes? Well, it's not common that they're already factored. So we have to have a plan B because it's not factored. Okay? So with that in mind, what methods have we talked about recently that we can use to find zeros before we go to the graph? What have we talked about finding? We did this back in, I don't know, 2.6, 2.5, somewhere in there. And then we used, once we came up with this list of numbers, we then used the calculator to check. Yeah. Okay, so when they ask you to do this algebraically, analytically, okay, start with your list of PRs. I'll let you use the graph to shortcut yourself so you don't have to, you know, go through and keep trying one till you find one that works. But that's going to be my suggestion here. What do you remember about PRRs?
It's a constant and one with the biggest variable.
Okay. So on top, it's factors of the constant, which are factors of 24, over factors of the lead coefficient, which in this case is 2. What are my factors of 24?
1 and 24.
1 and 24.
2, 12.
2 and 12.
3, 8.
3 and 8. You're missing one pair.
Does 4 have one?
Uh-huh.
4 is 16. 4 and 5 is 20.
4 and, someone help him out.
6.
6. Okay, so 4 and 6, 3 and 8, 2 and 12, 1 and 24. I just like to put them in order, so I was just writing down the first of each pair as they were said. Factors of 2 in the denominator are 1 and 2. Okay, now, with this in mind, I'll be honest, guys. In a scenario like this, okay, if I'm specifically saying, give me your list of PRRs, then I'm going to say, yes, go one more step. But in this scenario, where what is our next step, we're going to check the graph to decide which ones we want to use. This is a pretty easy list to look at, yes? You have 1, 2, 3, 4, 6, 8, 12, 24, and then you have any of those divided by 2, right? So you could, you could skip making that list out and just go and see what does the graph suggest we use. So, put in the graph, see what the graph suggests.
-2, 4, and
logarithm. Negative 2 and 4 should be obvious, and then 3/2 is kind of the,
Yeah.
well, I guess so at this point, you know. Okay, so negative 2, 4. Look fairly obvious. And then 3/2, well, it's got to be something between 1 and 2. It's got to be a real number because irrational occur in pairs. So between 1 and 2 is going to have to be 3/2. Okay? So the graph is going to suggest we try those. How do we try them? What do we do here?
The original problem?
Synthetic division.
Okay. Think of synthetic division. And this is going to be officially confirming that yes, they are zeros. Okay. So what are we using first? Negative 2? So if we put negative 2 in the box, 2, negative 7, negative 10, 24. Drop the 2. Negative 2 times 2 is negative 4. Negative 7, negative 4 is negative 11. Multiply. Negative 2 and negative 11 is 22. Negative 10 plus 22 is 12. Negative 2 times 12 is negative 24. And as expected, it works, yes? So what does that mean one of our factors is? If negative 2 works, one of my factors is, right, officially it's x minus negative 2, but it's x plus 2. That's one of my factors. Now, what's the next one we're supposed to try?
4, 3,
We can go with 4. Get the whole numbers out of the way. If we use 4 now, what am I going to suggest?
2, 11, 12.
Yeah, use this new set of numbers because we're factoring it down is what we're doing. So using 2, negative 11, 12. Drop the 2. 4 times 2 is 8. Negative 11 plus 8 is
8,
negative 3. 4 times negative 3,
12,
negative 12. Negative 12 and 12 are 0. As expected, it works. 4 works. What does 4 represent as a factor?
x plus or minus 4.
X minus 4. Now, we have another piece of information that we've just gained. Okay, you can try 3/2, but folks, what does this final piece of 2 and negative 3 represent?
2x minus
Okay, that does indeed represent 2x minus 3, which if you set that equal to 0 and solved it would be a 0 of 3/2. Okay, and so our purpose here was to factor this down. Okay, it doesn't factor using normal factoring techniques. Okay, however, it does factor, and that's what we just did here. So I'm going to rewrite f of x in its factored form. So this is the same thing that was right here. It factors into x plus 2, x minus 4, and 2x minus 3. And the whole point of factoring there is we can use that when we set up our sign chart. Okay? So like the sign chart yesterday, what numbers are going on my sign chart?
negative 2,
Negative 2,
3,
3/2, and 4. Order is important, yes. Spacing is not important. Order is important. And do some testing. Okay? A number left of negative 2. Okay, we can test with x equals negative 3. So, negative 3 plus 2 results in a
Negative.
negative. Negative 3 minus 4 is a negative. 2 times negative 3 minus 3 is a negative. What do you get when you multiply 3 negatives?
Negative.
A negative. Okay, what about between 2 and 3 halves?
0.
0 is an easy one to use there. 0 plus 2 results in a positive. 0 minus 4 results in a negative. 2 times 0 minus 3 results in a negative. A positive times negative is going to be a positive. Pick a number between 3 halves and 4.
2.
And it's not that you have to write down what number you're testing. You don't have to write that down at all. I'm just writing it down as these are our notes. This might be helpful when you go back and figure out what the heck did I do. So, okay, if we use 2. 2 plus 2 is a positive. 2 minus 4 is a negative. 2 times 2 minus 3 is a positive. 2 positives multiplied by a negative is a negative. And pick a number to the right of 4. So if we use 5, 5 plus 2 is a positive. 5 minus 4 is a positive. 2 times 5 minus 3 is a positive. 3 positives multiply to be a positive. Now, we've done all the work. The question is, what's our answer? What were we asking? What were we being asked? We're looking for where is our graph greater than 0? What does greater than 0 mean? Yeah. We're looking for where is the graph positive. So in which sections did my graph end up positive?
Negative 2, 3 halves, and then 4 infinity.
Okay. In the interval between negative 2 and 3 halves, and this interval to the right of 4, which is 4 to infinity. Now, infinity, I went ahead and put the parentheses on because infinities always get parentheses.
Negative 2, you get a bracket.
Okay.
Yeah.
Didn't you say yesterday it was parentheses?
Is it?
Yeah, it is. This might have been after you left actually yesterday. So now let's remember why. I'm asking where is this graph positive?
When it's touching, it's not.
And what is the graph doing at these 3 points?
0 is not positive.
Yeah, at these 3 points, at my zeros, my graph has a y value of 0. It's neither positive nor negative. They're only asking me about when is it greater than 0. So since it says greater than 0, I'm going to use parentheses. Now, if you want a hint of things to come, I might have a different opinion if it asked me when is my graph greater than or equal to 0.
Yeah.
Okay? So, but if it's just greater than, we're just looking for which sections is it positive. Okay, questions here. If I have a chance at the end of class, I'll look, but the next section in homework, so like the second section of homework, I don't know, 2, 4, 6, so probably like 8, 10, 12, that area, you're going to be doing this. In other words, I'm going to expect to see some work of you factoring it out, of your sign chart, those type of things. Okay? So just know that that's what I'm going to expect if you want full credit on homework tomorrow. Okay, ready for example 3?
Yep.
Okay, example 3 is about solving graphically. And the reason I made a point of what I was just saying is when we start solving graphically, the amount of work that is required to be shown decreases. Okay, because you're going to be using your calculator. And we're not going to have to, if it says to solve graphically, you're supposed to be using the graph. We don't have to worry about synthetic division and PRRs and all that. We get to go straight to the graph. Okay, so solving a polynomial inequality graphically. I know 34 to 44 are probably all graphically, and there's probably maybe some in the 2 through 20s that might be graphically. Again, I'll have to look. Now, what do we need to start with, though?
Set equal to 0.
Yeah, we need to get 0 on one side. And so in order to do that, I'm going to what? Subtract 2 over and add 8x over?
Yeah.
So when I write this out, I'm going to have x cubed minus 6x squared plus 8x minus 2 is less than or equal to 0. Okay? That is the graph we're looking at.
Uh-huh.
Okay? Now, with this one in mind, excuse me, what are we going to be asking ourselves in the end?
Where
it's less than or equal to 0.
Okay? We are going to be looking for where is the graph less than or equal to 0.
so negative.
What do we mean less than or equal to 0?
Negative.
Negative. Where is my graph negative?
Below the x-axis.
Okay, so 2 different ways to think about this, and I like both. Where is the graph negative is going to be one of the questions we're going to have to be considering. And when we talk about where is the graph negative, we're talking about it being below the x-axis. Now it says less than or equal to, so that means we're looking for where is it on or below the x-axis. Okay? Now, in order to do this problem, I know a bunch of you guys have already jumped ahead of me. That's fine. What are you doing? Yeah, you're going to have to graph it, yes. And then what are you going to have to find? The zeros. Okay? So we're going to graph. I'm just writing some notes here. Y equals x cubed minus 6x squared plus 8x minus 2. And then after you graph that, the question is going to be, what are the zeros? I have 2 decimal places on each of my zeros. Which, that gives us a hint. Why are we doing this one graphically and not algebraic? Besides the fact the directions told you to.
Because the zeros aren't, like...
This isn't factorable. Yeah, it's not going to factor into nice whole number answers. Okay? Okay. So your graph should look something like mine. I know you guys are long since ahead of me. With that in mind, you guys remember how to find zeros, yes? You're using your second calc zero function. And you're finding them all, yes? Left bound, right bound, and then my guess. Okay, it'll tell you right here, it says 0, y equals 0. Those are my ways I know that they're giving me the zeros. What are you guys getting?
0.32, 1.46.
4.21.
Okay, so 0.32 is the first one. What'd you say the second one was? 1.46
4.21.
and 4.21. You're not getting those answers on your calculator. A, check, make sure you typed in the right equation. B, ask me for help. Let me help troubleshoot the situation. Okay? I don't feel like you need me to demonstrate finding all those because that's old news at that point, right? Okay. No, we're not. Okay, we're not doing a number line. here's what we're doing. I'm going to sketch my graph on here. Okay, and it's just that. It's just going to be a sketch just so I can demonstrate what we're looking at. What's my graph do? It does an up, a down. It does something like that, right? Not exactly, but you get the idea. And we already discovered it crosses at 0.32, 1.46, and 4.21 according to our handy dandy calculators, right? Okay. I don't need to do a number line. I just need to look at my graph. Where are my answers?
A infinity, 132, 1.46 to 4.21. Parenthesis, bracket, bracket, bracket.
Okay. Why did he pick those intervals?
Because we're on or below.
Yeah. Original question was less than or equal to 0, which we then decided is anything that is on or below the x-axis. So basically we're looking for our sections that are below the x-axis. This section to the left of 0.32 is going to be negative infinity to 0.32. Now, why was I told a bracket this time?
Because we're equal.
Because it says or equal to 0. At that 0.32 number, my y value is 0. So we're going to use a bracket. And then the other section was also below the x-axis from 1.46 to 4.21. Basically, on this particular problem, they're all brackets. Because all those places it touches the x-axis, and it said less than or equal to. Now, this is where I say the amount of work that has to be shown drops off. I showed work here because there's certain things I was trying to put in your notes so you have them as a reference, right? Do you have to sketch the graph in your homework? No. Okay. Well, besides I had to get my equation equal to 0, I wrote down my zeros. I didn't really show much work, did I? Okay. I wrote us some notes. You guys don't have to do that in homework. So that's why I said there'll be certain ones I'm looking for work tomorrow.
So like, technically you could just write an answer and be done.
Pretty much, yeah.
If you have to set it equal to 0.
I mean, I would maybe, if you had to set equal to 0, write that out first. But other than that, no, there's not really work you have to show here. Okay? And I understand that. Okay. Backside. We've got some special cases that we need to talk about. And then down at the bottom, yeah, it's all kind of special cases on the backside, really. So let's look at some of these. Solving a polynomial inequality with unusual answers. Okay. Well, yes, this is in factored form. We are going to rely on the calculator here. Okay, we're relying on the calculator on this whole backside. So you're going to be graphing it. What is it I'm going to be looking for in the end? Where is my graph what?
Positive.
Positive. Okay. You're going to be looking for where is your graph positive. And in this case, that means, are we allowed to touch the x-axis? Yeah. On or above the x-axis.
It's basically just the same thing as the last problem. Answer-wise, like, you're not looking for much work.
Right, yeah, there's not really work to show. So go ahead and graph it. See what you can come up with as an answer.
Okay. I don't know if X noticed me. It's greater than everything's greater. Yeah, so like it negative infinity to 7. Or are we just gonna go from negative infinity to infinity? Negative infinity.
The question is, where is this graph positive? Well, what'd you get? Did you get what looks like the bottom of a curve or a parabola way up high? Does this ever go below the x-axis? Or, yeah, x-axis.
No.
It does not. It never goes below the x-axis, so this graph is always positive. Since the graph is always positive, negative infinity and positive infinity. Okay. I'm just going to write here a note. Graph is always positive. So my answer, negative infinity to positive infinity. As I said, it's a different answer, right? We got some specialty cases here. Questions there? Okay, B. This one, they give us an equation. It's less than or equal to 0. So this time we're looking at where is our graph negative, or in other words, on or below the x-axis. So you have to understand what it's looking for, what it's asking.
There's no 0. So,
There is. Yeah, there is. Zoom in. We're at negative 2.5. It don't look like it at first. So it would be, what would it be? Like 2.5 in brackets, maybe? Negative 2.5 maybe?
Okay, so first of all, the question is, where is this graph on or below the x-axis? Generally speaking, it's not, is it? Okay, it doesn't go below the x-axis, it looks like. Now,
I zoomed in enough, it touched it.
okay, and here's the deal. You have to be careful here because it does kind of look like, well, what's going on over there? So one option is doing some zooming in action and seeing what happens. And the more I zoom in, the more I might believe, oh yeah, that does look like it crosses the x-axis. Here's my thing, folks. Look at this equation right here. What would happen if you set 2x plus 5 equal to 0?
You get 5 over 2.
You would get negative 5 halves, right? Not that we had to do the algebra here, but can the algebra help you? It can, okay? And remember, an even power, multiplicity of 2, an even multiplicity says that it would touch, right? Remember we talked about that a little bit yesterday? So with that in mind, it does touch at negative 2.5. Does that ever go below? No. And so I believe the book will just put the answer, they'll use, instead of brackets, they'll use braces since it's just a singular number. I think I've done that some other point this year, is that they just tend to use the squiggly braces. And that just indicates it's just at that singular number. Okay? Questions if you have them, let me know. Otherwise, I'm just going to keep moving us through.
Just keep chugging and plugging. Plugging and chugging.
What?
Plugging and chugging.
Okay.
This is
What are we going to be looking for on C then?
Where it is less than 0, but not on the x-axis.
Okay. So we're looking for negative again.
It does.
The catch here is we just want to know when it is below the x-axis. Okay, I don't care when it touches the x-axis, when it's on the x-axis. I care when it's below.
Never.
alright. Calculator's frozen.
Hit the enter sign. No, just once. Because that's your pause button.
Yeah.
Did it do it? Okay. If your calculator, if your graph appears frozen, hit enter just once because you probably accidentally paused it.
Doesn't look like good blood.
It doesn't. I zoomed in.
Did you?
I did.
Did you?
I
Okay.
did.
So, as we look at this one, again, it's one where you need to investigate some, isn't it? Do some zoom in action, see what looks like it's happening.
Technically it goes to the negative power. So therefore, technically it's negative.
Henceforth that it is.
This one
Wait,
Is it?
kind of looks like a similar problem to last time. What number is that at?
0.
What x value?
Oh.
What was it? 1?
like about 1.
Yeah, because notice, you set x minus 1 equal to 0, it'd be x equals 1. What's this exponent of 2 saying it's doing there?
Touch it.
It's going to touch.
Cross.
Okay, it's going to touch it and go back up, as demonstrated here.
Therefore, none.
Our question was negative. Is my graph ever below the x-axis?
No.
No. If it said less than or equal to 0, we'd talk about 1. But it doesn't say less than or equal to 0. It just says less than 0. So we're going to say no solution. The graph is never below the x-axis. So writing a statement here along those lines, graph is never below x-axis. And so you could use the words no solution,
Yeah, please.
or you can use the symbol for empty set, which is a circle with a slash through it. That is the symbol for empty set.
No.
Okay? Okay. So those were just some unusuals where everything was above or below the x-axis. You had to decide how to answer there. Okay? My bottom pieces. As you start looking at the bottom section, it specifically says solve on the solve graphically on the calculator. Okay. Now, I'll have to do it. So in my notes here, solve the following inequalities graphically on the calculator. The book might say using a sign chart analytically, but we're going to do these on our calculator here. And actually, in all reality, what I'm going to try and get you to do is use your calculator with a little bit of knowledge about asymptotes and things together. Okay? So,
Anytime we see weird stuff, we use calculator.
well, the directions. Go by the directions. Now, as we look at A,
The book might say use a side chart.
as we look at A, notice there's there's fractions, yes?
Yeah.
What do the denominators do?
Asymptote.
A denominator will create a vertical asymptote, yes?
It does.
Okay, so I haven't graphed this yet, but I will here in a moment. But I know there's going to be vertical asymptotes at 2 places. Are you with me?
There is.
Where are there going to be vertical asymptotes?
-3 public one.
Can you guys support what he said? Remember, vertical asymptotes happen when you set the denominator equal to 0. And it's going to be important to know those numbers of -3 and 1. Okay? Now, some of you already graphed this, yes? If we graph this, what are we graphing? Because we are going to jump into the graph pretty quickly here. You're going to graph y equals 5 over x plus 3 plus 3 over x minus 1. Okay? That's what you're graphing. When we get to the end, what are we going to be asking ourselves? Where is my graph?
Greater than 0.
So I'm going to correct him.
Less
Less
than
than
0.
0. Dang, bro.
Okay.
Okay.
Where's my graph negative? Or in other words, where is it less than 0 or below the x-axis. Okay. Now, if you haven't looked at the graph,
So,
you should do so.
negative infinity to,
Hold on.
to, negative 3. It'll be like, whatever that 0 is.
Okay. You have a graph that looks like this, yes?
Something like that.
Okay. We had already discussed, or I had discussed, hopefully you followed, asymptotes at negative 3 and 1. Does that make sense? Are there 2 breaks in the graph? That's what I look at. Is I'm like, okay, I see a break at negative 3, a break at 1. I know for sure where those asymptotes are now. Now, what's the other piece of information we're going to have to know? You're going to have to know
The x-intercept, which is
that 0 there, yes?
Mhm.
I use the word 0. How can you find a 0?
second trace 0 left bound right.
Fancy dancy calculator, right?
It's negative 0.5. Mhm.
Okay, negative 0.5 or negative 1/2. Again, double check yourself. Make sure you remember, obviously at some point today you've tried to find a 0, I hope. Now, I am going to sketch my graph.
Do we?
Again, do you have to sketch the graph on the homework?
No.
No. I'm doing this just to put something in our notes. Okay. I said there's a vertical asymptote at negative 3 and at 1. Yes? We said that there's a 0 at negative 5/10. Okay? Or negative 1/2. Now, other than that, you can just kind of sketch your calculator based on what you're seeing on the screen, which it looks like it does this business. Looks like it does, ooh, that was kind of a crummy line there. This business, and it does that business, right?
Yeah, something like that.
Okay. All I did was put on my asymptotes and the 0, so I have something to go off of. Okay. Which sections of the graph do we care about?
Negative.
The negative ones, where my graph is below the x-axis. So here and there. I just kind of circled. Those are my answers, right, where I circled.
Mhm.
Now the question is, how am I going to express those intervals? This first interval, what in terms of x values is it?
Negative infinity to negative 3.
Okay. So negative infinity to negative 3. And part of the key information here is, does it touch negative 3?
No.
No, it's an asymptote, so parenthesis. Okay?
And then negative 1.
And then here, where does it start being negative again? When it crosses through that 0 at negative 1/2.
And it's both parentheses.
And so from negative 1/2 to, what asymptote is it approaching?
1.
1. So now we're going to say from negative 1/2 to 1. 1 is an asymptote. So it's definitely a parenthesis.
Because it's not equal to, that's also
Yeah.
parentheses.
So negative 1/2 goes back to, were we asking less than 0 or less than or equal to 0? We were just being asked, when is it less than 0, right? So I'm not going to use a bracket here when it's just less than 0. So it's going to be negative 1/2 with a parenthesis there. Okay, guys? Okay. I'm quickly running out of time. but there are some important, let's at least look at B real quick. There's an important help here that I want you to realize, okay? You guys know what you're going to graph when you go to graph this, right? You're going to graph the y equals parentheses x minus 3 and square root x plus 1. Now, let me tell you 2 key points that are going to happen here. Okay, I see 2 kind of factors in there. There's going to be key things happening at each of those factors. Right here, I'm just going to call them key points, and this will make sense once you look. X minus 3. If you set x minus 3 equal to 0, there's going to be a key point happening at x equals 3. You'll see when you get to your calculator that it ends up being a 0. Now, under the radical, what has to be true of anything under a square root? It cannot be negative. So it has to be positive. Positive. Greater than 0. So what's also going to help me here, well, okay, sorry, change my mind. So first of all, there's going to be a key point at x equals negative 1. The idea is that it would have to be greater than 0, and so x is going to end up being greater than negative 1. Okay, remember those numbers, 3 and negative 1. Have you graphed this yet?
Yeah.
Good, you're ahead of me. What was it? X minus 3
Square root x plus 1.
square root x plus 1. Okay,
Cha-ching.
we got the Nike swoosh.
Yep.
Okay, now, with this Nike swoosh, couple of important things. We said 3 was an important point. What's happening at 3?
It crosses. It becomes positive.
Okay, your graph crosses the x-axis, yes? Now, I said there was another important point.
Negative.
And this is important because it's hard to get this point from the calculator. Why is negative 1 important? What is that? Take a guess.
Asymptote.
It's not an asymptote, really, but it's as far as my graph goes. Okay? So right there, I know my graph, something like this, does something like that. Okay? That negative 1 is hard to figure out if you're just looking at the calculator. And so that's where I'm telling you it is important to realize, oh, that equivalates to that. Okay? Now, I skipped over the what are we asking ourselves here?
Greater than or equal to 0. So bracket 3 parentheses infinity.
Okay.
Infinity parentheses.
Greater than or equal to 0, so 3 to infinity. He said bracket. I agree. Are you guys okay with bracket?
It's equal to.
Okay. It said greater than or equal to. So I am using the bracket there because it does touch at 3. Okay? We didn't get to the last graph. Similar issues as the others. You'll be fine. I mean, you'll be as fine. You know, that one last graph isn't going to make a huge difference. Okay? So, yes, do the homework. Now, I'm trying to remember real quick as you guys are leaving. 2, 4, 6, I said goes with, that's the parts A, B, C from yesterday, right? 8, 10, 12. Use the sign chart algebraic on 8, 10, 12. Past 12, so starting at 14, everything, do it graphically. Okay? 34, it says use the sign chart, I'm saying graphic.
Heck yeah.
So, after 14, or starting at 14, you get to go calculator. Got it? Thank you, you too. Thank you. And for anyone viewing the notes, didn't get to the last example, but there is the homework assignment. And I'm going to put on here 2 through 12. use sign chart. Graph all others.